Hi guys, in this video I'm going to show you how to multiply and factor some polynomials. So these are two binomials. These are called binomials because there's two terms. So x is a term and 4 is a term. So that whole thing of parentheses is called a binomial. All right, so I am multiplying these two binomials together. I don't remember if you have ever been exposed to an area model, but basically we're going to just break this up into like a little box. I call this the box method of multiplying. And basically the box separates each term. So there's my x and positive 4 on one side. There's my x and positive 3 on the other side. And basically to do this problem correctly, we have to multiply all the terms from the one group to all the terms from the other group. So every single time you have x times x. X times x is always going to make a big X squared. X times x is x squared. So x times x is x squared. Whenever you're multiplying a constant times x, that's going to make your x terms. So 4 times x is 4x. Basically, that means you have 4 of these put together. So that's what 4 times x would mean. You have 4 of those x terms. So together you have 4x. All right, and the same thing down here when you do 3 times x. 3 times x means you have 3 x's. 3 times x means you have 3 x's. And then in the last box is just 4 times 3. Those are your ones. So the last box, we just have 4 times 3, your constant. So 4 times 3 is 12. All right, then we look and see what we can simplify. Well, if you notice with my x's, I had a group of 4 x's and I had a group of 3 x's. So I can combine those. I can put those together. If I combine those together, that comes out to be 7 x's. I have 7 x terms. So my final answer, I had an x squared term plus 7 x's altogether plus 12. That is my final answer. All right, so if you notice, how many terms do I have now? This is 3 terms, so this is now called a trinomial. The same pattern is going to happen every single time you multiply two binomials together. We're going to have x squared. I'm going to be adding 2 different groups of x's, and I should have a constant. So basically, I added 4 and 3 together to get the middle term. I multiplied 4 times 3 to get the last term. All right, so let's try another one. X plus 2 times x plus 6. X times x is x squared. 2 times x means 2 x's. 6 times x means 6 x's. And this just happens to work out to be the same number. 6 times 2 is 12. All right, and because I have 2 groups of x's, I am going to add those together. So basically, I ended up adding 6 and 2 to get the x term, and I multiplied 6 times 2 to get the term at the end. So my final answer, x squared, if I add those 2 boxes together, 6x plus 2x is 8x, and then the plus 12 at the end. All right, factoring is going in reverse with the same idea. So I want you to look at the previous example that we just did and look at my new example. think about, where did the x squared come from? Where did the x squared come from? The x squared came from doing x times x. So when I'm working backwards, I know those two are for a fact going to be in that same spot. X times x is how I got x squared. All right, it's also usually a little bit easier to jump to the end. How did we get 12? We did 12. We got 12 by doing 6 times 2. Is 6 times 2 the only way to get 12? No. I could have done 1 times 12, or I could have done 3 times 4. Those are all of the different ways that I can multiply two numbers together to get 12. The reason that 6 and 2 work is because if I add 6 and 2 together, they give me 8. So I kind of have to do the same thing when I'm working backwards. I want to think about, what could I have multiplied together that would give me the number at the end? In this case, it's 9. 1 times 9. 2 does not go into 9. And 3 times 3. Those are the only ways that you can multiply and get 9. I always recommend making a list and starting with 1 and just going number by number until you run out, or you see a number that you already have on your table. All right, so I know this last box came from multiplying one of these together to get 9. And the pair that I want has to add up to 10, because that's the term in the middle. So which pair do I want? I want 1 and 9. So here's how I'm going to check. X plus 1, x plus 9. This would give me 1x. This would give me 9x. And that looks good. Those definitely add up to 10. So my answer is x plus 1, x plus 9. And it doesn't matter which one you put where. Multiplication, the order doesn't matter. So you could put x plus 9 times x plus 1, and that's still the same thing. All right, so let's do one more. Now basically, every single one of these problems is going to be really similar. All right, so I don't have the factors. In a multiplication problem, these are called the factors. And this side is called the product. So in this case, I have the product, which means I have the answer, and I need to go backwards. I'm looking for the factors. So just like the last problem. So if I remember where things were, and I remember how I got them, I can work backwards to figuring out what the original problem looked like. So I know x squared. We do x times x to get x squared, so I know that. And I know that this last box would need to be 24. So I'm definitely looking for two numbers that multiply to 24. So I'm going to start listing them. I know 1 times 24, it's even, so I can divide it by 2. 24 divided by 2 is 12. I can check and see 24 divided by 3 is 8. 8 times 3 is 24. 24 divided by 4 is 6. So you see how I'm going in order. 1, 2, 3, 4. I'm going in order so I don't miss anything. And then 5 does not go into 24. 5 only goes into numbers that end in 5 or 0, so I'm going to skip 5. And then 6 is already on my list, so I know for a fact that I'm done. So my answer has to be one of these pairs. So which pair will add up to 10? 6 and 4, so I'm going to check. 6 and 4. So that will definitely give me 4 times x is 4x, 6 times x is 6x. They add up to 10x. They have to add up to the 10x. So that looks great. All right, so my answer is going to be x plus 4 and x plus 6. All right, and basically it doesn't really get any different than that. The only thing that we're going to start getting more comfortable with is negative numbers and knowing when to put a negative and when to put a positive. That's the main thing that we'll practice in class.